autoionization of water and ion product constant for water. Now water is autoionized, so it automatically ionizes itself. So we have a water molecule here ionizing with another water molecule. It produces hydronium ion and an hydroxide ion, and this is the ionization of water. The equilibrium constant and ion product constant for this reaction. The equilibrium constant for this reaction, as we worked out earlier, we know it's the products, the concentration of the products over the concentration of the acids. So we would get the concentration of the hydronium ions, the concentration of the hydroxide ions, you multiply those together and you divide it by the concentration of water and the concentration of water. So you would get two water concentrations. So in other words, you can square it. So this would actually look like this. To work out the ion product constant for this reaction, you simply rearrange that equation. So you would times both sides by the concentration of water squared, as you can see. So you are left with the ion product constant as being the concentration of the hydronium ions and the concentration of the hydroxide ions. Moving on. So these two, they have a constant. Because it's a constant, we have a specific number at 25 degrees Celsius. It is vital to know that it is at 25 degrees Celsius and nothing else. And the constant is 1.0 times 10 to the power of minus 14. Where the ion product constant Kw describes the following. In an aqueous solution, the product of the ion concentration of the hydroxide ions and the hydronium ions is a constant. So in any aqueous solution, these two are constants, and they are this is the value of the constant, and this is the unit. Now the unit is worked out by this equation here. M stands for the molar, and molar is the concentration unit. So here we have 2 molar. When you times them together, you would get m squared, and that's how you work out the unit at 25 degrees Celsius. A change in the hydronium ion concentration causes an inverse change in the hydroxide ion concentration, and vice versa. Now this is clear when you realize that this is a constant. So if this increases, then this has to drop in order for this to be a constant at all times. So that is what is said by this. And if the hydronium ion concentration drops, the hydroxide ion concentration will rise. And that is clearly because this is a constant.